Hi, this is Jonathan Wood from Soft Circuits, and in this video I'd like to talk a little bit about controls and how their messages are propagated that relate to events that happen within the control, and also what is referred to as reflection. I've got an application here, and to demonstrate what I'm talking about, this is a dialog box in my hex editor, and the under this bookmark list here is a simple regular list box, and that's a list box control. And here we have Microsoft SPI++, and that's a debugging program that comes with Visual Studio. And we're going to look not at the list box, but the parent of the list box, or the dialog box. And we want to see the messages that are sent to the dialog box. And there's going to be a lot, so we're going to narrow that down by just selecting the unknown, and that will include our what are called notifications. Let's start that up again. Now if I come over here to the bookmarks and I click it and change the selection, you'll see that two messages show up in the parent dialog window. And you'll see that the one of them is 0, and that's going to reflect the in this particular message, in this particular control, that's that appears to be reflecting the current selection. If I select the other one, that's the index of 0, we see we now have a 1 in the index of that second one. So the basic concept I'm trying to show is how controls are propagate their events under Windows. When Windows was designed, it wasn't designed using object-oriented programming. This was a little bit before object-oriented programming had become wildly successful and popular. And so the way that it was that you knew what happened to a control is the control would send what are called notification messages to the parent window. So for example, if you create a dialog box, and you could put a lot of controls on the dialog box, and then anytime like a button is clicked or anything like that, that notification is sent to the parent dialog, and so the parent window has to handle all those special events. Now in a lot of cases that still makes sense, and MFC still supports that, having the parent window handle control notifications. For example, if you click a button on a dialog box, it makes sense to have the dialog box process that click in response to the notification. But in other cases, it kind of goes counter to object-oriented programming. For example, let's say we want to change the behavior of the list box somehow. That can be done in Windows through subclassing and writing a lot of different hooks and code, but it doesn't really fit well into the C++ classes. And that's where message reflection comes in. Now, in short, message reflection means that the notification sent from the control to the parent window is redirected back to the class that is associated with that control. And this of course requires that the parent window is also an MFC CWin derived class. And the main advantage to that is this allows you to write classes that change the behavior of a control and then reuse those classes if you want that same behavior duplicated in other applications or in other locations within the same application. And if you still have to handle all those by the parent, then that's much harder to do because the parent window needs to handle all those different notifications itself in each place it is used. So we're going to find an example or create an example for that. I'll create a new project, an MFC application, and I'll just call it reflection. And since we're working with controls for this, I'm just going to make it a dialogue-based application and accept all the defaults. And let's go to the Resources tab and find the main dialog box. And let's get rid of that. And I'm just going to add an edit control. And to modify the behavior of this edit control, I'm going to create a new class. So we're creating an MFC class, and I'm going to call it C Yellow Edit. And it's important that I derive it from the edit control class, or C Edit. And click on Finish. And the class has been created and put into its own files. Now, if we go to the class we just created, and we look at the messages available with that class, you'll notice we have all the standard Windows messages, delete item, copy data, create, and all so forth. And then at the beginning we've got several messages with an equal sign at the beginning. Now the equal sign is an indication that these are redirected messages or reflected messages. For example, one of them is WM_control color. Now what normally happens is some controls send this message to the parent, and then the parent has a chance to override the color of the child control. And if we handle it here, we're actually handling it in the class associated with the child control, therefore bypassing the parent window. So let's go ahead and add that handler. Okay, and in order for this to work, I need to add a few variables to the class. And let's go ahead and initialize those variables in the constructor. So we're setting RGB text to black. And a background color to yellow. And we're then going to create a solid brush using the background color. And then in this control color handler, which remember is normally sent to the parent window, we have a device context, so we could go ahead and set the text color. And in addition, we return a brush, so we can return with a brush object. And with that done, we can go back to our dialog box. And now we need to associate that class with this dialog box. So I can right click and do add variable, and the assumption is it's going to be a C edit control, but we're going to change it to a C yellow, and we'll call it edit. Now that the category is set to control instead of value, control indicates that the variable represents the control itself and not a value returned from the variable, or from the control rather. And now that we've written that class and we've associated it with this edit control, we'll go ahead and run the project. And you'll see that our control is now yellow instead of the normal white. And let's go back and let's try changing the text color as well. We'll make it red. Now again, the thing that's important here is if we use the old way of handling Windows control notifications, such as the when the control is asking the parent window what color it should be, it really puts the burden on the parent window. And since we've have this in the class this way, and the control and the class are associated, and they all handle that themselves, there's much less burden on the parent windows, and instead it would be very easy to add this control to other places in the application or other applications. And in fact, let's go ahead and add another one. So we'll add the edit control. And we'll right click, add variable. Need to make sure it's of type C yellow. Type C yellow edit. And we'll call it wind yellow edit 2. And we can run that. And again, that's all it takes now to add that functionality to another control. So that's a very convenient way to handle that. And of course, our custom logic could get very complex depending on what we're doing. And so it's nice that the parent window doesn't have any burden to deal with that, other than just making sure it uses the right class that's associated with the control. And that's in part due to message reflection.